conversation about Arabic machine translation, and this is episode number 8 of our Arabic NLP series. And today we will explore the challenges faced in translating Arabic and dive into the strategies and tools used in both rule-based and also the statistical translation approaches. And also, I am going to explain at the end uh, the recent part and the state of the art, let's consider it, where we depends on neural machine translation, sequence to sequence transformers, and also large language models to perform this task. So we are going to see the challenges in the history and also how they are modified and explored. And also we're going to see the impact of sequence-to-sequence transformer and large language models in achieving high performance in Arabic machine translation. Okay, so machine translation is the process of automatically translating text from one language, which is called the source language, to another language, which is the target language. And we have like two main approaches to this task. We have the traditional approach, which is the rule-based. We call it RMPT, which relies on linguistic rules and dictionaries. And more recent methods use like statistical MT, which is known as SMT, which is learn the translations from large data sets. Okay, and also we have seen like hybrid models that merge these two approaches for better performance. But if we want to talk deeply about rule-based machine translations, which involves building a system for linguistic rules and describe how words and phrases are translated between languages. And here we come to two sub-methods. We call the transfer MT and the interlingual MT. The transfer MT maps between the syntactic structures of languages, and the other one, which is the interlingual MT, which is focused more on the meaning or semantic. So these systems often require manually built resources such as translation dictionaries. Okay. On the other hand, we have the statistical MT, which is of course on corpus-based and learned from parallel text, as you can see here, with of course word alignment between the source and the target text. So SMT produced a ranked list of possible translation using translation and language models. Okay. Yeah, so there is like a multilingual comparison of Arabic with other languages to understand the challenges in Arabic and MT. So it's helpful to compare Arabic to other language like English, Spanish, Chinese, and Arabic differs greatly from these languages in its orthography, morphology, and syntax. And if you have seen previous videos, I have described and explained more details about how Arabic language is somehow not easy in terms of orthography or morphology and syntax. Okay. So these differences lead to specific translation challenges that affect the strategies and methods used in both rule-based and statistical systems. So talking about Arabic orthography uh, and comparison with other languages, we see that Arabic use a reduced alphabet with optional diacritic, okay, which add some complexity to the task of tokenization. And this is a middle ground compared to English and Spanish, which have also very simple and alphabet-based scripts. Okay, and also if we look to the Chinese language, which use a much more complex systems with over 10,000 characters. Also, we have uh, Arabic morphology, which is also a complex system. Since Arabic stands out as a morphologically rich language, for a more complex than English and Spanish. And this complexity leads to many word forms that SMT systems have difficulty managing due to the issue of sparsity, and many word forms are rarely seen. Okay, so tokenization helps solve this by like breaking down Arabic word into smaller parts. Maybe it's like improving the translation quality. And lastly, we have the syntax in this conversion and focusing on verb-subject order. Uh, since Arabic syntax allows flexibility with the order of subject and verbs, meaning we can have like both verb subject and subject verb. Okay. Uh, so for example, this كتب الولد, the boy wrote, it can be like verb subject and subject verb. Okay. By the way, Spanish shares this flexibility with Arabic due to its pro-trope natural, okay? And English and Chinese tend to stick to a more to subject verb order, okay? State of the field in Arabic MT, we have seen like Arabic English MT has seen like a lot of development in recent years with many large-scale parallel corpora and evaluation like in IST and MEDAR assessing the quality of translation systems. And also we have some of the most well-known tools that handle Arabic like Google Translate and Bing Translators. And Sakhar's Tarjum in the Arabic like development field, but still there are challenges. Like one key is the tokenization, breaking down complex Arabic words into similar units for processing. Another, like we have the syntactic reordering, okay, and this is very important. It's especially when translating Arabic verb subject object structures into English subject verb object structures. Okay, so and also we have like after translating into Arabic, we need to recombine the parts into grammatically correct forms. Okay, this is a process we call it like the tokenization. But are these challenges anymore exists? The current state of machine translation, especially with neural network and large language models. Okay, Arabic, let me just be more specific here and explain more. Today, Arabic MT has moved like far beyond the traditional statistical and rule-based approach with the introduction of neural machine translation and we can see models that are produced for more accurate and fluent translations. We have like the sequence to sequence architectures of the transformer, which is power system like Google Translate and other models. Of course, we can see now like the popular one in RT5 and other models. On the other hand, we have the rise of large language models like GPT, BERT, which are fine-tuned for Arabic and allows for more advanced contextual understanding. And these models enable like zero-shot translation, where the system can handle translation tasks, and hasn't been like explicitly trained for. Okay. And also the focus, by the way, is shifting towards handling Arabic dialects and raw resource languages, which is like an area that was historically challenging. So now with LLMs, we can better manage these challenges and improve the quality of the translation in all forms of Arabic. Okay, so regarding the previous mentioned challenges, like the tokenization complexity, where LLMs handle Arabic morphology more effectively with subword tokenization, reducing like the data sparsity and improving fluency. And also deep learning now and deep neural network that combine with the transformer and the whole architectures like allow for smoother reordering from Arabic VSO that we explained to English SVO without syntactic parsing errors. Okay, and LLMs generate grammatically accurate Arabic outputs, and even for the transfer learning from MSA to dialect for Arabic, we see now LLMs like performing better and better by leveraging these multi-language training data sets. And soon I am going to show you more examples about how to perform fine-tuning using a very state-of-the-art, I consider it, which is ARA T5 model, which has shown great performance in translating from languages to Arabic and Arabic to other languages, okay, and also in dialects. So all that we are going to explain, but I wanted from this video to give like an overview about this. So thank you and hope that's like helpful for you.